Good morning, my dear students. So once again, we are starting a fresh week. So we are already continuing the P block, lesson 2 in the inorganic chemistry. So in this, after finishing the 13th group, in the 14th group, we started with the electronic configuration and then the 4 types of allotropical forms, particularly the graphite, diamond, fullereness, and then the graphene. We discussed about all those allotropical forms. Now we are taking up the compounds of carbon. Today we are going to deal about 2 compounds of carbon. The first one is carbon monoxide, which is called the molecular formula C double bond O. Right? Its preparation is done by 3 methods. Right? The first preparation is done using air. When carbon is heated with limited supply of oxygen, it will produce carbon monoxide on heating under reduced pressure and temperature. Right? So there should not be excess of oxygen, there must be limited supply of oxygen. And this has to be balanced. 2 oxygen, so multiply this by 2, so 2 carbon atoms will be used. The second preparation is done also from carbon. Here it is using the atmospheric air. So carbon is to be heated with oxygen containing nitrogen, and this is heated to a high temperature and pressure. Right? So carbon, 2 carbon will take the 2 oxygen, forming 2 carbon monoxide, and nitrogen gas is produced. So the mixture of these 2 is usually called as producer gas. So in this producer gas, there is nitrogen, and this nitrogen can be absorbed. Right? This can be absorbed by passing through cuprous chloride. If we pass through the cuprous chloride solution, nitrogen will be absorbed and we will get the pure carbon monoxide gas. Right? And the third preparation is from formic acid. So in organic chemistry, when you say acid, it is having what functional group? COOH. Formic acid will have H with COOH. Right? This is to be treated with concentrated sulfuric acid. What is concentrated sulfuric acid? We should know the role of concentrated sulfuric acid. Whenever concentrated sulfuric acid comes in reactions of carbon compounds, it will absorb water. It will remove water molecules. So H2O will go out. When H2O goes out, what will remain there? Carbon monoxide will remain there. Very simplest method of getting carbon monoxide from formic acid. So this acid is called formic acid. So at least 2 acids, organic acid, we must be very familiar. Formic acid and acetic acid. So acetic acid ke CH3COOH irukum, formic acid ke HCOOH. These are the 2 acids we will get very often in plus 2 syllabus. So these are the 3 preparations of carbon monoxide. First 2 preparations from carbon, and the third preparation is from formic acid. This carbon monoxide is a odorless gas. It's a colorless gas. It will burn with a blue flame in air, and very important physical property of this is it is a poisonous gas. Right? So in many films we see in the operation theatre, they cut off oxygen supply and they give carbon monoxide to take the patient into coma stage. Right? There are so many movies which have come like that also. So carbon monoxide we should not inhale. It will affect the blood circulation and it will take us to coma stage. We will become unconscious for a long time, years together. Right? That's why off-burnt carbon should not be in our living place also. So carbon monoxide is a very dangerous gas. It should not be inhaled. It is poisonous. It is toxic. It will affect our systems. Then its chemical properties. Right? The first property is with air. When carbon monoxide is burnt with oxygen, heated with oxygen, it will become carbon dioxide gas. So this is a simple reaction that takes place. Then similarly, its reaction with chlorine. Carbon monoxide can react with chlorine, forming carbonyl chloride. This carbonyl chloride is known as pasgene. So the 2 mark, 3 mark, how is pasgene prepared? Pasgene nave we should know it comes from carbon monoxide, right? Then carbon monoxide is used as a reducing agent. Yeah, about this reducing agent, we have studied this in the Ellingham diagram itself, right? Carbon monoxide can react with ferric oxide, and we'll get iron with carbon dioxide being liberated. So iron preparation, iron extraction, the reaction vandirukkum, right? How to balance this, right? We have 3 oxygen to join with 3 carbon to form 3 carbon dioxide, and we get 2 iron in the form of the metal that's being reduced, right? Then the 4th reaction is formation of methanol, right? The carbon monoxide with the excess of hydrogen is called as syngas. It's called synthetic gas. This, on heating to high temperature and pressure, will lead to the formation of an alcohol, which is called methyl alcohol, and this is called methanol. Right? The equation is balanced: 1 carbon, 4 hydrogen, and 1 oxygen atom. Right? And the 5th one is known as oxo process. So spontaneous oxidation that is taking place with carbon monoxide. When carbon monoxide is heated with ethylene along with hydrogen gas, right? And this leads to the formation of an aldehyde, CH3, CH2, CH4. There are 3 carbon, there are 6 hydrogen, 3 plus 2, 5, 5 plus 1, 6, and there is 1 oxygen. So this is called propanaldehyde. Right? So this is being called as the oxo process. Right? After that, we have got 2 more properties. This is Fischer-Tropsch process, where carbon monoxide is used to prepare alkanes and alkenes by treatment with hydrogen. So when carbon monoxide is heated with 2n plus 1 time of hydrogen gas, right? It forms CnH2n plus 2. This is called alkane. Along with that, we get n number of water molecules, right? So this is called Fischer-Tropsch process. Or the n carbon monoxide is heated with 2n hydrogen atom, then it becomes CnH2n plus NH2O, and this becomes alkene, right? So both can be taken as the example for Fischer-Tropsch process, right? And the last reaction is that of formation of carbonyls. Formation of carbonyls, right? For example, nickel on heating with carbon monoxide will form nickel carbonyl, right? Chromium on heating with carbon monoxide will form chromium carbonyl, and copper on heating with carbon monoxide will form copper carbonyl. So like that, it easily combines with metal, forming the carbonyl compounds. So that is the chemical properties of carbon monoxide, right? And finally, we write the structure of carbon monoxide. Right? The structure of carbon monoxide. So in this, carbon has got 6 electrons, 1s2, 2s2, 2p2. It has got 4 electrons, and oxygen has got 8 electrons, 1s2, 2s2, 2p4. It has got 6 electrons. So carbon forms a double bond between oxygen, and 2 electrons will be left here, and 2 electrons will be involved in bonding. Oxygen is 6 plus 2 are involved in bonding, other 4 will remain here, right? Or it can have a resonance. If the bonding electron shifts to this side, it becomes single bond. In that case, it will have this will become minus and this will become plus, because it has given its electron. The electron கொடுத்துருது. இது எலக்ட்ரான் கொடுத்ததுனால பிளஸ் ஆயிடுது. இது எலக்ட்ரான் வாங்குறதுனால அது என்ன ஆயிடுது? மைனஸ் ஆயிடுது. இதுல ரெண்டு எலக்ட்ரான் இருக்குது. ஒரு எலக்ட்ரான் கார்பன், ஒரு எலக்ட்ரான் ஆக்சிஜன். ரெண்டுமே இங்க போயிடுச்சுனா கார்பன் எலக்ட்ரான் இது வாங்கிக்குது. That's how that minus comes. Or the other possibility is that it can shift this way also. In that case, this will become minus. Right? And this will become plus. So this is the resonance structure of carbon monoxide. It can be existing in 3 different forms. Its bond length is about 1.126 Armstrong. Right? So carbon monoxide is a very important gas. It is used in the reduction of metal oxides to metal. So metal extraction it is being used. It is used in the synthesis of alkenes. It is used to prepare producer gas and water gas. Water gas is a mixture of carbon monoxide and hydrogen. Producer gas is a mixture of carbon monoxide and nitrogen. These two gases are used in the industry as a fuel, right? So carbon monoxide is also used as a ligand in making the carbonyl compounds and coordination compounds. So these are the uses of carbon monoxide. The next compound that we are going to see is carbon dioxide. Break